Hello everyone. In this video, I will talk about floating point representation, which here I talk about decimal, floating point representation, and binary. So for the decimal floating point representation, they are usually called scientific notation with formal T0, T1, T2, T3, and Tn, and power of p. So this part is called mantissa, and this part is called exponent. So 10 power of p, also called numbers order of magnitude. So let's hear an example. I also want to mention that for the numbers order of magnitude, we have two cases. If t0, t1, tn is less than 5, then the order of magnitude is shown by t power of p. But if the t0 point, t1, t2, t3, tn is greater than 5, then the order of magnitude is shown by 10 power of p plus 1. Example, we have a number 4519.23. So for this number, the decimal floating point is 4.5192.3 10 power of 3. So the order of magnitude, because this number is less than 5, so this is 10 power of 3. And number of significant digits for this number is 1, 2, 3, 4, 5, 6. 6 significant digits. Example 1. So for example 2, I give you another example, 732.5051. So the scientific notation or decimal floating point representation is 7.32505.1 10 power of 2, because this number is greater than 5. Following this, the order of magnitude is 10 power of p plus 1, which is 3. And number of significant digits are 1, 2, 3, 4, 5, 6, 7. 7 significant digits. For the second case, binary floating point, these numbers are in form of 1 point d1, d2, d3, dn to power of b1, b2, bm. So again, this part is called mantissa, and this term is called phonics. So this is 2, not Z, A2. So we see that we have n plus 1 significant digits in here and 1 for 1 here. So in order to convert a number in binary floating representation, you should follow 2 steps. Step 1, called normalization, which you actually divide the number by the largest power of 2. Divide by largest power of 2. It should be smaller than your number. I show you example. For step 2, the p power here and mantissa will be converted to binary. And I show you example of how to do that. So one example for converting a number in base 10 to binary floating representation. For example, we want to do that for 50. For 50, we should find the largest power of 2, which is less than 50. I'm going to write power of 2 here. So this is 1, this is 2, this is 4, 8, 16, 32. This one is 64. Now you see that 50 is here. So then you should select 2 power of 5. So normalization, the first step is 50 is 50 over 2.5 times 2.5. So if you divide 50 by 2 power of 5, that will be 1.5625 to power of 5. Now this is the mantissa. and this is exponent. Now you should convert mantissa and exponent to binary form as well. So for the mantissa, which is 0.5625, what is this number in binary form? If you see my previous video, in order to do this, we times this number by 2, so it would be 1.125. So we extract the integer, which is 1, and then write only the fractional part. Again, we multiply by 2. The answer would be 0.25, which we extract the integer, which is 0, and we write the fractional only, which is again 0.25. So we multiply by 2, 5. We write the integer, which is 0, and we write the fractional, which is again 5. So when we multiply again by 2, the answer is 1. We write the integer, which is 1, and here we write the fractional, which is 0. So the fractional of 1 is 0. So once the fractional is 0, we stop the computation. Answer is here B1, B2, B3, B4. So which means 1, 0, 0, 1, base 2. So this is mantissa, and 5 also should be converted in exponent, which is 5, should be converted in base 2 as well. So in order to convert 5, because 5 is the integer, the integer part, instead of multiple by 2, we divide it by the base 2. So the quotient is 2, and the first remainder is 1. So again, we divide the quotient by 2. So we see that the next quotient is 1, and next remainder is 0. Now, if you divide it again by 2, the quotient is 0, and remainder is 1. So once the quotient is 0, you stop the computation, and the number will be A0, A1, A2, which is 1, 0, 1 power of in base 2. Okay, so back to here. So this number 1 point, the mantissa is 1, 0, 0, 1, 2 power of 5. 5 in binary is 1, 0, 1. Yeah, so the number 50 in binary representation is 1.1001 to 101. And number of significant digits are 5. 1, 2, 3, 4, 5. Okay, so I hope you enjoyed this video, and goodbye.